So, how do you teach a robot to think? I don't just mean following a set of commands, but actually understanding the world around it. What if I told you the key wasn't about pure logic, but about giving it an imagination? Let's dive into how researchers are building an inner world for AI. Okay, take a look at this robot arm. It's holding a little red block. Now, what's going to happen if it just lets go? You know the answer, right? The block's going to fall, it'll clatter right onto the surface below. Simple. You don't even have to think about it, did you? You just knew. That's because your brain is running these little, tiny, effortless simulations of physics all the time. It's this deep intuition we build over our entire lives. But for a machine, that simple prediction is like trying to solve a super complex physics equation in a split second. It is anything but simple. And right there, that's the massive challenge for AI. How do you give a machine that same kind of gut feeling about the physical world? How do we teach it to guess what happens next without forcing it to memorize every single possibility in the universe? This brings us to a really cool idea, actually building an inner world for an AI. The goal here is to give machines a kind of imagination, like a mental sandbox where they can play out what might happen next before they do anything. In the AI world, they call this a world model. Think of it this way. You don't need to remember the exact position of every single grain of sand to understand what a beach is. You just get the concept of a beach and how waves work. A world model does that for an AI. It helps it understand the rules of the game, not just the pixels on the screen. But here's the catch. There's a huge problem. This internal map of reality the AI is building, turns out it's incredibly fragile. For a long, long time, these models would just break. This failure actually has a name, representation collapse, and it's just as bad as it sounds. It's a total catastrophic failure, where the AI's understanding of the world basically short circuits. All the distinct concepts it's learned, cats, cars, coffee cups, they all just merge into one. It can't tell the difference between anything anymore. So why did this keep happening? Well, the old methods were kind of like a Rube Goldberg machine, just a jumble of super complex, patched-together parts. They needed all these different mathematical rules to be perfectly balanced. They often had to lean on these massive pre-trained models, and they needed all sorts of special hacks just to keep them from completely falling apart. And with all that complexity, it was just so easy for it to fail. The AI's entire, rich, detailed map of the world could literally just crumple into a single, useless point. It would start seeing everything as the same thing, a block, a button, the floor, all identical. Its imagination would just go blank. But what if the solution wasn't adding more complexity, but taking it away? A brand new approach called LeWorldModel comes up with a surprisingly simple and really elegant fix. And it all boils down to one simple rule. The secret sauce is a single, powerful mathematical rule. Imagine trying to keep a group of people spread out in a room. You could give everyone specific coordinates, which is really complicated. Or you could just tell them, hey, everyone stay at least 6 feet apart. This rule is like that simple instruction. It just keeps the AI's different concepts from clumping together, making sure its understanding stays diverse and detailed. And the difference is just night and day. The old way, you had to tune 6 or more different settings, kind of like trying to get an old tube radio to work just right. LeWorldModel, it has just one knob. It learns everything it needs to know from scratch, just by watching videos. And its stability isn't some temporary trick. It's baked right into its core design. So here's how it all works in 3 easy steps. First, a component called the encoder looks at a frame of video and boils it down into a compact, abstract idea. Then, a predictor takes that idea and imagines what the world is going to look like in the very next moment. And this is the most important part, step 3. That simple mathematical rule, which the researchers call SIGReg, acts like a guardian, constantly making sure the AI's imagination stays rich and never, ever collapses. Okay, so the theory is beautiful, it's elegant, but does it actually work? Well, this is where things get really, really impressive. Because this new model is so much simpler and more efficient, it can plan out its actions up to 48 times faster than the old complex models. That is a staggering jump in speed. I mean, this chart just lays it all out. To plan a series of actions, the old method took about 47 seconds. The new, simpler LeWorld model, less than 1 second. That is the difference between a robot that has to stop and think for almost a whole minute and one that can react in the blink of an eye. But here's the real question, right? Is it just fast, or is it actually smarter? Does it have a deeper, better understanding of the world? To figure that out, the researchers basically peeked inside the AI's brain. They checked if its internal thoughts lined up with real-world physics, like the position and speed of objects. And as you can see from this table, for both position and velocity, LeWorldModel got a consistently higher score. Its internal map wasn't just faster, it was a more accurate reflection of reality. So, what does this all mean? Why does a faster, more stable AI imagination even matter for our future? Well, it means we're finally moving away from robots that just calculate things and toward robots that are developing a genuine intuition for the physical world. They can actually anticipate the consequences of their actions, not just follow some rigid script somebody wrote for them. And that just unlocks incredible possibilities. We're talking about factory robots that can adapt to new situations on the fly, self-driving cars that can better predict what other human drivers are about to do, and truly smart assistants in our homes that can understand the physical context of what we're asking. As the researchers themselves put it, this gets us a lot closer to one of the central goals of AI, creating a single unified way for machines to learn a huge variety of skills just by watching the world around them. This is a huge leap forward. It's a simpler, more stable way to give machines an imagination. So the next time you see a robot, don't just wonder what it's doing, wonder what it's imagining. Because that is where the future of AI really begins.